In this module, we are going to talk about banana cultivation. Let's start with the importance of banana and different production scenarios in major banana growing states of India. Banana, which is Musa special, is the second most important fruit crop in India next to mango. Its year-round availability, affordability, varietal range, taste, nutritive and medicinal value makes it the favorite fruit among all classes of people. It also has good export potential. Also, in India, banana ranks first in production and third in area among fruit crops. It accounts for 33% of production of all the fruits and 13% of the total producing area. Production is highest in Maharashtra, which produces 39,000 tons, followed by Tamil Nadu, which produces 35,000 tons. Within India, Maharashtra has the highest productivity of 65.7 tons per hectare, against the national average of 30.5 tons per hectare. The other major banana producing states are Karnataka, Gujarat, Andhra Pradesh, and Assam. Another feature of banana is that it is a high-tech cultivation of the crop and it is economically viable enterprise leading to increase in productivity, improvement in produce quality, and early crop with the produce. That is, banana commands a premium price. Now, let's understand the different aspects which contribute to good growth of banana, like soil and climate, seasons, etc. We will start with soil and then we will study climate. Soil fertility is very important for successful cultivation. As banana is a heavy feeder which has a restricted root zone. Hence, depth and drainage are the two most important considerations in selecting the soil for banana. The soil suitable for banana should be 0.5 meters to 1 meters in depth. It should be rich, well-drained, fertile, moisture retentive, and should be containing plenty of organic matter. Extreme clayey, sandy soil, saline soil, and calcareous soil is not suitable for banana cultivation. We also need to avoid soils of low-lying areas and soils which are very sandy and heavy black cotton with ill drainage. The next point of importance is the pH. The range of pH should be between 6.5 to 7.5. Now, let us start with the climate. There are a variety of climatic factors which contribute to banana growth and yield. Let's look at them one by one. The first one is altitude and latitude. Banana is a tropical plant requiring a warm and humid climate. It can be grown from mean sea level to an altitude of 1200 meters. The latitude for banana is 10 degrees north to 12 degrees north. Temperature. It can be cultivated in a temperature range of 10 degrees Celsius and 40 degrees Celsius with high humidity, but at temperatures of 20 degrees Celsius and less, and at temperatures of 35 degrees Celsius or more,
the banana plant growth is retarded,
and the temperature is 24 degrees Celsius or more for a considerable length of time, then banana plant gives a higher yield. The next part of climate is rainfall. Banana requires a mean annual rainfall of 100 mm per month. Stagnation of water is injurious and may cause diseases like Panama wilt. Humidity. A humidity of at least 50% or higher is recommended since the banana plant is native to hot and humid parts of the world. Dry air will damage the banana leaves. Sunshine and light. The banana is native to parts of the world where the sunshine is very strong and the sun has a bright light. Approximately 12 hours of strong light is recommended for most types of banana. Wind. Wind exerts profound influence on growth and production of banana. The wind velocity of more than 50 km per hour causes serious damage to banana plantation. Different types of lands are suitable for banana cultivation. Let us now understand the season and varieties which are best suited for each type of land. For the type of land which is wetland, the best time for planting in wetlands are between February to April and April to May. The varieties of banana which are most suitable for planting between February to April are Puvan, Rasthali, Manthan, Karpuravali and Nepuvan. For April to May, the banana variety which are most suitable are Nendran and Robusta. For the type of land which is garden land, the best time for plantation is between January to February and November to December. Robusta, Nendran, Dwarf Cavendish are the best varieties which are grown well in garden lands. For hill banana, the best time for planting is between April to May and between June to August. Namaran, Ladan, Manoranjitham, Surumalai and Virupakshi are the best varieties which grow well in hill banana. For the land type which is tissue culture banana, the best time for planting is throughout the year, except when the temperature is too low or too high. Grand Nain is the best variety which grows well in tissue banana. There are two different types of propagation method for banana: vegetative method and tissue culture method. Let us start with vegetative method. Commercial bananas are seedless and propagation is exclusively by vegetative means. Banana is mostly propagated by rhizomes and suckers. Since banana is highly unstable in genetic constitution, the suckers of rhizomes should be selected from plants which are healthy, having all the desirable bunch qualities and high yielding abilities, possessing at least 10 hands a bunch. The next one is tissue culture banana. Banana plants are also propagated through tissue culture. Varieties like Shrimanti, Gros Michael and Grand Nain are commonly produced using tissue culture technique. How does the tissue culture method work? Normally, disease-free plantlets with 3 to 4 leaves are supplied in pots for raising secondary nursery. Plants are initially kept in shade, which is 50% shade, and as they harden, shade is reduced gradually. This process takes approximately 6 weeks. After that, plants do not require any shade. Normally, 2 months of secondary nursery is good enough before the plants are to be planted in the field pits. Now let's understand the selection process of suckers for planting purpose and their related pest and disease control measures. Let's start with the selection process. Select sword suckers of 1.5 to 2 kg weight free from any diseases and nematodes. This will help ensuring a healthy plant growth. Trim the roots and decayed portion of the corn and cut the pseudostem, leaving a space of 20 cm from the corm. This is a treatment. Let's continue with the treatments. To avoid wilt diseases in the plant, infected portion of the corm may be pared, dipped for 5 minutes in carbidazim, which is Mangala Akraman, 0.1%, using 1 gram in 1 liter of water for Rasthali, Manthan, Nevyanan, Virupakshi, and other wilt-susceptible varieties. To control nematodes in plants, following options can be used. Apply pralinage along with 40 grams of carbofuran, 3 grams granules, which is Mangala Gold, per sucker. Dip the corm in the slurry solution prepared by using 4 parts clay plus 5 parts water and a sprinkle of carbofuran to control nematodes. Carbofuran is in Mangala Gold. One can also alternatively dip the corm with 0.75% monocrotophos, which is Mangala Mahakil, and shade dry for at least 24 hours before planting. So, sun hemp on the 45th day, incorporate it after about a month. This operation reduces nematode buildup. Use well-hardened tissues from cultured banana plants with 5 to 6 leaves. At the time of planting, apply 25 grams of Pseudomonas fluorensis per plant. Let us now understand the different methods of field preparation required for different types of land used for growing banana. The basic field preparation activities are: the land is prepared by deep ploughing and harrowing. Through which the soil is brought to a fine tilth. Then farmyard manure is added at the rate of 25 cartloads per hectare at the time of ploughing. Pits of 0.45 into 0.45 into 0.45 meters are dug at desired spacing on the ploughed fields. Pits are then refilled with topsoil mixed with 2 kg of FIM, 250 grams of Mangala neem cake per powder, and 20 grams of Mangala Gold, which is humic granules. Now we will understand the different types which are used for different type of lands. That is, the different methods which are used for different types of lands used for banana cultivation. When we are growing the banana on wetlands, then no preparatory cultivation is necessary. One can place the suckers at ground level and earth up. For garden land, 2 to 4 ploughings are needed to prepare the right type of soil for growing banana. For Padugai, 1 deep mamutti digging is required, and for hill banana, remove scrub jungle and construct contour stone walls to enable banana cultivation. After preparing the field, it's important that the banana plants are planted with the right spacing. The spacing details for planting details of tissue culture banana variety Grand Nain under drip irrigation systems is the next thing we will study. So tissue culture banana variety Grand Nain under drip system. Spacing of 1.82 into 1.52 meters with 3,614 plants per hectare are recommended. The major advantage of planting banana crops for variety Grandnain is that it saves the cost of drip irrigation system. In this method, deep planting should also be avoided, and a week after planting, spray streptocycline 500 ppm at the rate of half gram per liter. The spacing requirement and planting requirement for different varieties for different land types. For the land type, garden type, and for the varieties which are Robusta and Nendran, the spacing requirement is 1.8 into 1.8 meters and number of plants per hectare required are 3086. For the variety garden land, for the banana variety, which is dwarf Cavendish, the spacing requirement is 1.5 into 1.5 meters and the number of plants per hectare required are 4444. For the land type, which is wetland, for the varieties which are Puvan, Monthan, Rasthali, Nivyanan, and Nepuvan, the spacing requirement is 2.1 into 2.1 meters and number of plants required per hectare are 2267. For the banana varieties growing in hill, the variety which is Virupakshi and Namarai and Ladan, the spacing requirements are 3.6 meters into 3.6 meters and number of plants per hectare required are 750. There are three types of irrigation methods commonly followed for banana cultivation. These are flood or furrow irrigation, trench irrigation, and drip irrigation. Let's look at them one by one. The first one is flood or furrow irrigation. It is the most common method of irrigation under garden land cultivation. In this system, the water consumption is very high and it is a very costly method with uneven distribution of water and fertilizers. There is also a chance for fast spread of nematodes in the banana crops irrigated using this method. The second type is trench irrigation. It is a popular method of irrigation under wetland system of cultivation. In this method, the water is allowed to stand in the trenches opened between every two rows of plants and the same is used for draining out the excess of water during rainy days. The third method is drip irrigation. It is the method of applying uniform and precise amount of water directly to the root zone of the plants as per the requirement. This application is run through emitters at frequent intervals over a long period of time via a low pressure pipe network comprising of mains, submains, and laterals. The soil moisture is always maintained at field capacity of the soil, and hence the crops grow at a faster rate consistently and uniformly. Through this method, the water can be saved up to 40%. So these were the three methods of irrigation: flood or furrow irrigation, which is good for garden land; trench irrigation for wetland; and drip irrigation, which saves water. In flood irrigation, we need to irrigate immediately after planting is complete. Post that, after 4 days, we need to give live irrigation. For subsequent irrigations, the number of days gap between irrigation changes with the land type. For irrigated plantation of garden land plantation, we need to do a subsequent irrigation once a week. However, for wetlands, we need to do a subsequent irrigation in 10 to 15 days. In all scenarios, irrigate the fields copiously after every manuring. The total amount of the irrigation water required for flood irrigation at different age of crops is given in the following chart. When the age of the crop is 55 days or 60 days after planting, then 8 liters of water is required approximately per plant per day. When the age of the crop is between 61 to 90 days after planting, then 16 liters of water approximately is required per plant per day. When the age of the crop is between 91 to 120 days after planting, 24 liters of water approximately per plant per day is required. When the age of the crop is between 121 to 150 days after planting, 32 liters of water approximately per plant per day is required. When the age of the crop reaches 181 days till flowering and bunch formation, the amount of water required is 48 liters approximately per plant per day. And when the age of the crop is at bunch maturity, then the amount of water required is approximately 56 liters per plant per day. When we are using the drip irrigation method instead of the flood irrigation, then we need to irrigate the crops using 15 liters of water per plant per day from planting to 4th month. Then we need to increase the water from 15 liters to 20 liters per plant per day. From 5th month to shooting, the water requirement is 25 liters per plant per day. And from shooting to harvest, the amount of water required is 15 liters per plant per day. Now we will understand the micronutrient requirement, the important micronutrients recommendation for a banana plant. The important micronutrients required for banana crop are zinc and boron. Zinc deficiency is common in saline soil, which has no or little organic content. Zinc deficiency is characterized by small and narrow tapered leaves with intervenial chlorosis. New leaves that emerge are small in size. Flowering process gets delayed. and it also results in bunches becoming small with bottle-necked fruit. This all happens due to zinc deficiency. On the other hand, boron deficiency results in production of small deformed leaves. This also leads to veins becoming prominent with streaks across the veins on the leaf called as laddering symptoms. To recover a plant from zinc and boron deficiency symptoms, we can use the following fertilizers in the mentioned quantities. We can apply Mangala zinc sulfate 21% to the crop at the rate of 15 kgs per acre. We can apply a combination of Mangala zinc 33% and G as granules at the rate of 5 kgs per acre with Mangala general mix at the rate of 10 kgs per acre. During 40 to 50 days after planting, use foliar spray of Mangala Adbor at the rate of 2 grams per liter of water. Use of adventz granobor at the rate of 3 kgs per acre during the 4th month and the 6th month after planting is recommended. It is recommended for rectifying the deficiency and also for improving bunch weight. Let us now see the impact of nitrogen deficiency on a banana plant. As we can see in this image, the visual nitrogen deficiency symptoms are yellowing of the leaf tissue, which first occur in older leaves, followed by the midrib from the leaf tip. The second image shows how the leaves start shaping as V-shaped wedge because of the deficiency, and in general, the plant becomes yellowish green and chlorotic in nature as demonstrated in this image. As a quick recap, nitrogen deficiency symptoms are yellowing of leaves, V-shaped wedges, and yellowing of the plant. Nitrogen is essential for photosynthesis and it is a part of proteins and enzymes. What are the management measures for nitrogen deficiency? To ensure adequate nitrogen is provided to the banana plant, we can add and spray 5 grams per liter of water of Purna 19, which is a water-soluble fertilizer, or use 5 grams per liter of water of Calnit 19, which is also a water-soluble fertilizer. The next deficiency symptoms we study are of phosphorus. Following images show the visual phosphorus deficiency symptoms in a plant. As it can be seen, phosphorus deficiency results in poor root and shoot growth, as we can see from the images on the screen. The leaves of the banana plant turn blue or pinkish green but not yellow. Phosphorus is essential for photosynthesis, flowering, formation of starches and sugars. To rectify phosphorus deficiency symptoms, we need to spray the crop with Atom 61 or Boost 52. These are both water-soluble fertilizers at the rate of 5 grams per liter of water. Now, let us understand the impact of potassium deficiency on banana plant. Potassium deficiency leads to the margins of the leaves becoming yellow and scorched due to deficiency. It can be seen in these images. These images show the different part of the plants getting impacted due to potassium deficiency. It also leads to lodging of plants. The seeds and fruit are also impacted and are misshapen. As a recap, the deficiency symptoms of potassium are margins of the leaf becoming yellow and scorched, lodging of plants, seeds and fruits are misshapen. Potassium is essential for photosynthesis, fruit quality and pest resistance. To rectify potassium deficiency symptoms, we need to spray the crop with Boon 45 at the rate of 5 grams per liter of water or Boost 52 at the rate of 5 grams per liter of water. The next deficiency we study is the calcium deficiency. Following images demonstrate the visual calcium deficiency symptoms in a banana plant. As it can be seen from these images, calcium deficiency results in lodging of plants and terminal buds and root tips fail to develop normally. Soft fruit blossom but end up rotting. Let's recap. The deficiency symptoms of calcium are terminal buds and root tips fail to develop normally, soft fruit, blossom and root, lodging of plants. Calcium is essential for proper functioning of growing plants, especially root tips, cell division and elongation. To rectify calcium deficiency symptoms, we should spray the crops with Calnet 19, which is a water-soluble fertilizer, at the rate of 5 grams per liter. The next one is magnesium deficiency. These images highlight the visual magnesium deficiency symptoms in a banana plantation. The leaves of the plant develop intervenial chlorosis, yellowing, and red chlorotic areas. Recap. Magnesium deficiency symptoms are intervenial chlorosis, yellowing, and red chlorotic areas. Magnesium is essential for photosynthesis and it aids the plant enzymes to function. The management measures to rectify magnesium deficiency symptoms are spraying of Mangala magnesium sulfate at the rate of 5 grams per liter, and for soil application, Mangala magnesium sulfate at the rate of 50 kgs per acre is recommended at the time of earthing up. The next one is iron deficiency. The visual symptoms of iron deficiency are dryness of branches and leaves, resulting in yellowing of leaves. We can also see a clear distinction between the veins and chlorotic areas of the impacted leaves. Let's recap. Iron deficiency symptoms are dryness of branches and leaves, yellowing of leaves, and a clear distinction between veins and chlorotic areas. Iron is essential for photosynthesis and chlorophyll formation. To rectify iron deficiency symptoms, we need to spray iron EDTA at the rate of 2 grams per liter, and for soil application, we need to apply ferrous sulfate at the rate of 15 kgs per acre. The next one is zinc. The visual zinc deficiency symptoms are formation of small sized leaves and deformation of leaves. The middle leaves develop intervenial chlorosis and suffer from stunted growth, as we can see from the images. Let's recap. The deficiency symptoms of zinc are small size of leaves, deformed leaves, middle leaves with intervenial chlorosis and stunted growth. Zinc is essential for enzyme activation and is vital in metabolic processes in plant cell. To rectify zinc deficiency symptoms, we should spray the crop with zinc sulfate 21% at the rate of 5 grams per liter. In case of soil application, we need to apply Mangala zinc 33% G at the rate of 5 kgs per acre. The next deficiency is boron deficiency. Following images demonstrate the boron deficiency symptom. We can see how the fruit and the leaves are impacted. Boron deficiency leads to chlorosis in leaves and splitting of fruits. Let's recap. Boron deficiency symptoms are young leaves, often terminal buds, become light green at base. Leaves become twisted and brittle and die back at growing point. It leads to chlorosis of young leaves and splitting of fruits. Boron is essential for seed and cell wall formation, maturity promotion, translocation of sugars, germination of pollen grains and pollen tubes. To rectify boron deficiency symptoms, we need to spray the crops with Adbor at the rate of 2 grams per liter and in case of soil application, we need to apply Granbor at the rate of 3 kg per acre. Now we study the schedule for Mangala specialty plant nutrients. So SPN is Mangala specialty plant nutrient schedule application for banana crop production. At the time of planting, which is the stage of root initiation, we should apply Mangala cetrite at the rate of 150 grams per plant, Mangala Biogold at the rate of 100 grams per plant, and Mangala neem cake at the rate of 50 grams per plant in pit fill with soil for better establishment. During initial vegetative state, which is 25 days after planting, spraying of Mangala Kelpak Sanjeevani at the rate of 4 milliliter per liter as foliar spray on leaves encourages good root and shoot development. Soil application of Mangala General Mix at the rate of 25 grams per plant and Mangala Zinc G 33% at the rate of 10 grams per plant are recommended at vegetative growth stage, which is at 40 days after planting. Mangala Zinc 33% G and Mangala General Mix soil application method is soil application at the base of the plants. It needs to be followed by foliar spray of Mangala Bio 20 at the rate of 4 milliliter per liter. This is for vigor, vegetative growth of plants. To promote rapid vegetative growth, foliar spray of Mangala 3X is recommended. It needs to be applied at 55 days after planting in the vegetative state at the rate of 4 milliliter per liter as a foliar spray on leaves. Mangala 3X contains more nitrogen and other essential elements that boost up the growth of plants. 90 days after planting, which is big earthing up, the application of Mangala Gold at the rate of 25 grams per plant and Mangala Magnesium Sulfate at the rate of 50 grams per plant is recommended. This needs to be applied around the base of the plant in 1 feet distance in the root zone and cover this with soil, which is side dressing. In banana, the stage of before flowering is at 150 days after planting. At this stage, application of Mangala Calinit 19 or Mangala CN is recommended to encourage good flower initiation. This is also applied as side dressing. 220 days after planting, which is the stage of hand emergence, the spraying of Mangala Cap Plus is recommended at the rate of 4 ml per liter as a foliar spray on flowers. This application helps or encourages fruit setting. The bunch and fruit development and enlargement is favored by spraying of Mangala Restore 2, which contains 40% potash. This spray is done at 235 days after planting and then after a 20-day interval at 255 days after planting. That is, at finger development and at fruit development, we need to apply Mangala Restore 2 at the rate of 4 ml per liter as bunch spray. At 265 days after planting, which is the stage of fruit development, we need to apply or spray water-soluble fertilizer Mangala SOP or Sulfo 50 for bunch maturity stage to increase the quality of banana fruits. These images show the effect of Mangala SOP spray on banana bunch development. These images show the crown feeding operations in banana and their effect on stunted banana plants. The crown feeding procedure is applying Mangala Bio 20 at the rate of 8 ml per liter of water and pour 100 ml at the top of each stunted banana plant to stimulate the growth and new emergence of leaves to maintain uniform heights of plants in the banana field. The recommendation of bulk fertilizer for banana growth under flood irrigation systems are: first one is for all banana varieties except Nendran growing under garden land. These varieties require nitrogen at the rate of 110 grams, phosphorus at the rate of 35 grams, and potassium at the rate of 330 grams per plant. For the Nendran variety growing in the garden land, the nitrogen requirement is 150 grams per plant, phosphorus is 90 grams per plant, and potassium is 300 grams per plant. These requirements are all on annual basis, that is per year basis. For banana varieties except Nandran, Rasthali, Puvan and Robusta growing in the wetland, the nitrogen requirement per year is 210 grams per plant, phosphorus is 35 grams per plant and potassium is 450 grams per plant. The varieties which are Nendran and Rasthali growing on wetland, their requirement is 210 grams of nitrogen per plant per year, 50 grams of phosphorus per plant and 390 grams of potassium per plant. For Puvan and Robusta growing in wetland, the nitrogen requirements is 160 grams per plant per year, 160 grams of nitrogen per plant per year, 50 grams of phosphorus per plant per year, and potassium is 390 grams per plant per year. The nitrogen and potassium fertilizers should be applied in 6 splits. They start from first time at the time of planting, and subsequent doses are given at 45 days, 90 days, 135 days, 180 days, and 210 days after planting. This is shown in the timeline. Whereas phosphorus should be applied at the time of last plow of the field preparation, or it should be applied at the time of planting rhizomes. Now, let us understand the concept of fertigation. We will start with the definition of fertigation, that is, what is fertigation? Fertigation is a method of applying fertilizers and other water-soluble products required by the plant during its growth stages through drip or sprinkler irrigation. The application of nutrients through irrigation systems is called fertigation. This is a contraction of fertilization and irrigation. The fertigation schedule differs based on banana varieties, growing conditions, water and fertilizer quality, and type of land. Why is it required for banana crop? Banana requires heavy nutrition. Banana crop requires 7 to 8 kgs of nitrogen, 0.7 to 1.5 kgs of phosphorus, 17 to 20 kgs of potassium per metric ton yield. Banana responds well to application of nutrients. Traditionally, farmers use more of urea and less of phosphorus and potassium. What are the benefits of fertigation? Fertigation results in 25 to 30% increase in yield. It saves labor and time, and the distribution of nutrients is uniform. Now, let us look at the fertigation schedule for banana variety Grand Nain. The blanket recommendation of NPK, nitrogen, phosphorus, potassium for Grand Nain is 200 is to 55 is to 400 kg per NPK per plant. Normally, the total number of plants under drip system per acre is around 1100 per acre. The given quantity of fertilizer is for 1 acre of banana plants per day, and it is not mandatory to give this prescribed quantity every day, and it can be given once in a week or 10 days according to field condition and plant requirement. But the quantity of fertilizer should be added. That is, if the recommended quantity is 0.6 kg per day, then if the farmer is giving once in 10 days, then he has to add for the 10 days quantity and should give 6 kgs in fertigation. During the initial stages of growth, which is 15 to 60 days after planting, the banana plant should be fertigated with Mangala 19-19-19 or Purna 19 at the rate of 0.6 kgs per acre per day. And the total quantity to be given for 45 days then is 27.5 kgs per acre. And similarly, Mangala MAP or Atom 61 should be given at the rate of 0.5 kgs per acre per day. The total quantity leading up to 23 kgs, and Mangala urea has to be given at the rate of 1.2 kgs per acre per day, and the total is 55 kgs per acre for the entire 45 days. The second schedule of fertilizers should be given between 60 to 120 days after planting. The Mangala MAP or Atom 61 should be given at the rate of 0.85 kgs per acre per day, and the total quantity therefore is 50 kgs per acre for 60 days, along with Mangala KNO3 or Boon 45 at the rate of 0.5 kgs per acre per day, and Mangala urea at the rate of 1.2 kgs per acre per day, and the total quantity to be given along with Mangala MAP or Atom 61 should be 30 kgs per acre of Mangala KNO3 or Boon 45 and 60 kgs per acre of urea for the entire 60 days. Then during the same period, Mangala magnesium sulfate has to be given separately at the rate of 0.8 kgs per acre per day, and the total quantity to fertigate is 48 kgs per acre for the entire 60 days. In this application, care should be taken to not mix Mangala magnesium sulfate with any other fertilizer, and it should be given separately. The third schedule is planned for 120 to 150 days after planting. The fertigation of Mangala MKP or Boost 52 has to be given at the rate of 1 kgs per acre per day, with a total quantity of 30 kgs per acre for the entire 30 days, along with Mangala MOP White at the rate of 1 kg per acre per day, with the total quantity being 30 kgs for 30 days. Mangala urea at the rate of 1.2 kgs per acre per day, the total quantity being 36 kgs for the entire 30-day duration, and Mangala zinc sulfate 21% at the rate of 0.8 kgs per acre per day, with a total quantity of 24 kgs for the entire 30-day period. The fourth schedule is planned at 150 to 180 days after planting. Fertigation with Mangala urea at the rate of 1.2 kgs per acre per day, Mangala CN or Calnet 19 at the rate of 1 kgs per acre per day, and Mangala MOP White at the rate of 1 kgs per acre per day, with the total quantity of 36 kgs per acre for Mangala urea, 30 kgs per acre for Mangala CN or Mangala Calnet 19, and 30 kgs for Mangala MOP White for the entire 30 days. In this fertigation schedule, the water-soluble fertilizer Mangala CN or Calnet 19 is not compatible for mixing with any other fertilizer, and hence it should be given separately to the banana plants. The fifth schedule is planned for 180 to 210 days after planting. Fertigation should be done with Mangala urea at the rate of 0.6 kgs per acre per day, Mangala KNO3 or Boon 45 at the rate of 2 kgs per acre per day, and Mangala CN or Calnet at the rate of 1 kg per acre per day, with a total of 18 kgs per acre for Mangala urea, 60 kgs per acre for Mangala KNO3 or Boon 45, and 30 kgs per acre for Mangala CN or Calnet. In this fertigation schedule also, we should take care of not mix Mangala CN or Calnet with any other fertilizer, as it is not compatible, and hence Mangala CN or Calnet should be given separately. The final fertigation schedule is planned for 210 to 280 days after planting. Fertigation with Mangala MOP white at the rate of 2 kgs per acre per day with a total quantity of 140 kgs per acre for the entire 70 days should be given for the banana plantation. The next plantation schedule is for banana variety Kadali and Nendran. The blanket recommendation of NPK for the banana variety Kadali and Nendran is 165 is to 50 is to 400 kgs per NPK per plant. Normally, the total number of plants under drip irrigation system per acre is around 1100 per acre. The first schedule is planned during the initial stages of growth, which is 15 to 60 days after planting. And the banana plant should be fertigated with Mangala All 19. Mangala All 19 or Purna 19 at the rate of 0.5 kg per acre per day, and the total quantity to be given for 45 days is 23 kgs per acre. Similarly, Mangala MAP or Atom 61 at the rate of 0.5 kgs per acre per day with a total quantity of 23 kgs should be given, and Mangala Urea at the rate of 1 kgs per acre per day should be given, gives us a total of
46 kgs for the entire duration.
schedule. The second schedule of fertilizers should be given between 60 to 120 days after planting. The Mangala MAP or Atom 61 should be given at the rate of 0.75 kgs per acre per day, and the total quantity for 60 days is 45 kgs per acre, along with Mangala KNO3 or Boon 45 at the rate of 0.5 kgs per acre per day, total quantity being 30 kgs, and Mangala Urea at the rate of 1 kgs per acre per day with the total quantity being 60 kgs. During the same period, Mangala magnesium sulfate should also be given at the rate of 0.8 kgs per acre per day, and the total quantity to fertigate is 48 kgs per acre for the entire 60-day period. In this fertigation schedule, we need to take care to not mix Mangala magnesium sulfate with any other fertilizer and make sure that Mangala magnesium sulfate is given separately. The third schedule is planned for 120 to 150 days after planting. The fertigation of Mangala MKP or Boost 52 at the rate of 1 kg per acre per day with a total quantity of 30 kgs per acre for the entire 30 days, along with Mangala MOP white at the rate of 1 kg per acre per day with a total quantity of 30 kgs per acre for the entire 30 days duration, along with Mangala Urea at the rate of 1 kgs per acre per day, total quantity being 30 kgs for the entire 30-day duration, and Mangala zinc sulfate 21% at the rate of 0.8 kgs per acre per day with the total quantity being 24 kgs. The fourth schedule is planned for 150 to 180 days after planting. Fertigation with Mangala Urea at the rate of 1 kg per acre per day, Mangala CN or Calnet at the rate of 1 kg per acre per day, and Mangala MOP white at the rate of 1 kg per acre per day with a total quantity of 30 kgs for each one for the entire 30-day time period. Here, the water-soluble fertilizer Mangala CN or Calnet is not compatible for mixing with any other fertilizer, and therefore it needs to be given separately to banana plants. The fifth schedule is planned for 180 to 210 days after planting. This time period requires Mangala Urea at the rate of half kg per acre per day, with the total quantity being 15 kgs for the entire 30 days. Mangla KNO3 or Boon 45 at the rate of 2 kgs per acre per day, with the total quantity being 60 kgs per acre, and Mangla CN or Calnet at the rate of 15 kgs per acre per day, with a total quantity of 30 kgs per acre for the entire 30-day period. Mangla CN or Calnet is not compatible for mixing with any other fertilizer, and hence it should be given separately. The final fertigation schedule is planned for 210 to 280 days after planting. Fertigation with Mangla MOP white at the rate of 2 kgs per acre per day should be done, with a total quantity of 140 kgs for the entire 70-day period. The next fertigation schedule is for the banana variety red banana. The blanket recommendation of NPK for red banana is 140 is to 42.5 is to 280 kgs per NPK per plant. Normally, the total number of plants under drip irrigation system per acre is around 700 numbers per acre. The first schedule for red banana fertigation is planned during the initial stages of growth, which is 15 to 80 days after planting. And the banana plants should be fertigated with Mangala All 19 or Purna 19 at the rate of 0.4 kgs per acre per day, and the total quantity to be given for 65 days is 26 kgs per acre. Similarly, Mangala MAP or Atom 61 is also to be given at the rate of 0.2 kgs per acre per day, the total quantity being 13 kgs for the total of 65 days. And Mangala Urea at the rate of 0.8 kgs per acre per day also has to be given, with the total quantity being 52 kgs for the entire 65 days. For the entire 65 days. The second schedule of fertilizers should be given between 80 to 150 days after planting. The Mangala MAP or Atom 61 should be given at the rate of 0.4 kgs per acre per day, and the total quantity is 28 kgs for the entire 70 days, along with Mangala KNO3 or Boon 45 at the rate of 0.5 kgs per acre per day, with a total quantity of 35 kgs for 70 days. Mangala Urea also has to be given during this period at the rate of 0.6 kgs per acre per day, with the total quantity being 42 kgs for the entire 70-day period. And lastly, we also need to give Mangala magnesium sulfate at the rate of 0.7 kgs per acre per day, with the total quantity to fertigate is 49 kgs per acre for the entire 70 days. When we are giving all these 4 fertilizers during the second schedule, we also need to take care that we do not mix Mangala magnesium sulfate with any other fertilizer, and we should give it separately. The third schedule is planned for 150 to 180 days after planting. The fertigation is done with Mangala KNO3 or Boon 45 at the rate of 1 kgs per acre per day, with the total quantity being 30 kgs for the entire 30 days, along with Mangala Urea, which is put at the rate of 0.6 kgs per acre per day, with the total quantity being 18 kgs for the entire 30 days period, and Mangala zinc sulfate 21% at the rate of 0.8 kgs per acre per day, with the total quantity being 24 kgs for the entire 30-day period. The fourth schedule is planned at 180 to 220 days after planting. Fertigation should be done with Mangala Urea, which is applied at the rate of 0.5 kgs per acre per day, with the total quantity being 20 kgs for 40 days, and Mangala KNO3 or Boon 45 at the rate of 1.2 kgs per acre per day, with the total of 48 kgs for the entire 40 days. The fifth schedule is planned for 220 to 260 days after planting. Fertigation should be done with Mangala urea at the rate of 0.25 kgs per acre per day, with the total quantity being 10 kgs for the entire 40-day period. Mangala SOP or Sulfo 50 at the rate of 1 kg per acre per day, with the total quantity being 40 kgs. Mangala MOP White at the rate of 2 kgs per acre per day, with the total quantity for 40 days being 80 kgs per acre. And Mangala CN or Kalinite at the rate of 0.75 kgs per acre per day, with the total quantity being 30 kgs for the entire 40-day period. The final or the sixth fertigation schedule is planned between 260 to 300 days after planting. Fertigation with Mangala SOP or Sulfo 50 at the rate of 1 kgs per acre per day, with the total quantity being 40 kgs for this time period. Mangala MOP at the rate of 2 kgs per acre per day, with the total quantity being 80 kgs. And Mangala CN or Kalinite at the rate of 0.75 kgs per acre per day, with the total quantity being 30 kgs for the entire 40-day period. Let us now understand the intercultural operations which benefit the farmers. First activity we'll understand is weedling. Spraying plantation with glyphosate, which is Mangala Samhar, before planting at the rate of 10 to 15 milliliter per liter to keep the plantation clean. 1 or 2 hand weedlings are also necessary. Next is the removal of the male floral bud, which is called denaveling. Removal of male bud helps fruit development, which increases bunch weight. Male buds are removed with last 1 to 2 small hands with a clean cut, keeping a single finger in last hand. Earthing up. Keep the soil loose by harrowing from time to time. Earthing up should be done 3 to 4 months after planting by raising the soil level around the base of the plant by 10 to 12 inches. It is better to prepare a raised bed and keep the drip line on the bed 2 to 3 inches away from the plant. Next one is trashing. The dried leaves should be removed as and when seen. Please ensure that leaves are not cut. Propping or supporting the bearing plants can be done by suitable propping material like a stick with V shape at one end. Covering the bunches. Covering the bunches with perforated 0.4 millimeter thick white or blue polythene bags, as is shown in the image, when all the hands have emerged, prevents blemishes, diseases, insect damage, and also results in early maturity of the fruits. Spotless fruits have more export potential and hence fetch better market price. The next thing we talk about is harvest. Harvest is the time when ripe products are sold. The harvest details for bunch maturity and other visual symptoms are being discussed here. The dwarf bananas are ready for harvest within 11 to 14 months after planting, while tall cultivars take about 14 to 16 months to harvest. A bunch usually takes 90 to 120 days to mature after shooting. The visual symptoms which act as an indicator of maturity are: the maturity of banana is indicated by drying of top leaves, change of color of fruits from dark green to light green, and tendency of the floral end of the fruit to fall by the slightest touch by hand. The mature fruit becomes plumpy and all the angles are filled in completely. When tapped, the fruit gives metallic sound. Let's see the yield per hectare for different varieties of banana at the time of harvest. For the variety which is Puvan and Rasthali, the yield is 40 to 50 tons per hectare per year. For Manthan, the yield is 30 to 40 tons per hectare per year. For Nepuvan, the yield is 30 to 35 tons per hectare per year. For Robusta, it is 50 to 60 tons per hectare per year. For Grand Nain, it is 70 to 80 tons per hectare per year. And again, for Grand Nain, under high density planting, the yield is 115 to 130 tons per hectare per year. Thank you.